You know, long before we had watches or clocks on our phones, humanity had this massive, super reliable timekeeper just hanging out above our heads, the sky. For thousands of years, we've looked up not just in awe, but, well, to check the time. So let's get into how that all works.
Our story starts at this really vibrant kite festival, Makar Sankranti. And there's this girl, Mira. She's flying her kite, watching it dance in the sky, when she spots something a little unusual, something that gets her thinking.
And that's her question. But it's my question for you too. Have you ever looked up into a bright blue sky and just seen the moon? Kinda hanging out there? It feels a little weird, doesn't it? Well, Mira thought so, and her curiosity is going to be our starting point.
Okay, to really understand this cosmic clock, we have to start with the most basic piece of time we all live by, the day. And the day, that's all about the sun. I want you to picture our planet as this giant, complex machine, like a clock. The very first, most important gear in that whole thing is its own spin. This constant turning on its axis is what gives us the rhythm of our lives, that simple, reliable cycle of day and night.
So how did our ancestors measure this rhythm so precisely? It's genius, actually. They used a stick. That's it, a stick in the sun. By watching that shadow, you can find the exact moment the sun is at its highest point in the sky, because that's when the shadow is shortest. And the time between one shortest shadow and the next, bam, you've got yourself one solar day.
But here's a little twist. Because the Earth's path around the sun isn't a perfect circle, it's more of an oval, the actual time from noon one day to noon the next changes just a tiny bit all year long. So to make things easier, scientists came up with an average called the mean solar day, and that average is what we've locked in as our 24-hour day. Okay, so we figured out the day, but that brings us right back to Mira's other puzzle. It wasn't just seeing the moon during the daytime that got her thinking, it was also how it's always changing shape. This leads us to our next great timekeeper, the moon and the rhythm of the month.
Yeah, I mean, she knew the moon was a big sphere, right? So why doesn't it always look like one? Why do we get these little slivers and half moons and sometimes nothing at all? It's a really good question.
And the answer, it turns out, is all about perspective. See, the moon doesn't make its own light. It's really just a giant, gorgeous mirror reflecting the sun's light. The shape we see from down here on Earth just depends on our angle as the moon makes its trip around us.
Yeah, it's all about our point of view. The sun is always lighting up one half of the moon, but as the moon circles the Earth, how much of that lit up half we can see changes. Sometimes we get the whole show, sometimes just a tiny slice, and sometimes none of it. This shows the two extremes perfectly. During what's called Purnima in India, or the full moon, we're right between the sun and the moon, so we see the whole bright side. But at Amavasya, or the new moon, the moon is between us and the sun. The side facing us is totally dark, so it basically disappears.
So how long does it take for the moon to go through this whole cycle of phases, from one new moon all the way around to the next? It takes about 29.5 days. And this predictable, repeating rhythm gave us our next big unit of time, the month.
All right, so we have the day from Earth's spin and the month from the moon's orbit. Now let's zoom out one last time and look at the biggest gear in this whole cosmic clock, Earth's trip around the sun each year. We're looking at the same system, but now from a much wider view. That huge journey is Earth's revolution around the sun. And this trip doesn't just move us through space, it actually creates the seasons that define our year.
The time it takes for Earth to make one complete lap around the sun, for all the seasons to cycle through, is about 365.25 days. And this, of course, is our year. Oh, and that little 0.25 of a day? That's exactly why we have a leap year every 4 years. Pretty neat, huh?
So we have a day, a month, and a year, all given to us by these steady, repeating movements in the heavens. So what did people do with this amazing information? We used it to create one of our most important tools ever, the calendar. And this is really the beautiful part of it all. The Earth's spin every day, the moon's phases every month, and our planet's orbit every year. These three cosmic rhythms are the natural blueprint, the absolute foundation for every single calendar we've ever made.
So let's just break it down nice and simple. The Earth's rotation gives us the day. That's universal. The moon's phases give us the month, which is the whole idea behind lunar calendars. And finally, the Earth's revolution gives us the year, the backbone of solar calendars.
So, different cultures had to decide which cycle was most important to them.
Solar calendars, like the one most of us use, are all about tracking the seasons, which is super important for farming. Lunar calendars stick strictly to the moon's phases, often for festivals. And then you have lunisolar calendars, which are this really clever attempt to keep track of both the moon and the seasons.
You know, a quote from one of the sources we reviewed just says it all perfectly. The various cycles observed in nature resulted in the creation of calendars. They weren't just some random invention. They were our way of making sense of the beautiful, predictable clockwork of the universe. We saw the pattern, and we built a system to live by it.
So we've seen how our one moon shaped our idea of a month, which leaves us with a final, kind of mind-bending question to think about. How would our calendars, our culture, our whole night sky be different if we looked up and saw two moons? What would time even look like then?